Good evening, everyone. My name is Dr. Servet Yatin, and I have the honor of serving as the Provost and Chief Academic Officer of Quincy College. Thank you all for coming for our second Scholarly Conversations. Last year, we assembled Scholarship Teaching and Learning team to generate ideas for bringing Quincy College to the community. One of the team's many excellent ideas was this event, Scholarly Conversations. This event is not just a way to showcase our talented faculty, it is a way for us to say thank you to our community members and all of the support you provide us. Before we start, I would like to ask all team members please to stand for a round of applause for putting together this terrific event. Thank you. I also want to thank our member of board of our governors and Representative Frank Santoro. Thank you for being here. Thank you for all you do, and thank you for coming. Now, a few housekeeping items. Please silence your cell phones, President including. So silence your cell phones for the remaining of the evening, please. Restrooms are outside near the entrance, and in case of emergency, please follow the exit signs. This evening, we have 3 distinguished speakers with a Q&A following each speaker. I will have the honor of introducing each individually, but not before I introduce President Richard DiCristofaro. A great leader and a great supporter of this event, President DiCristofaro.
Thank you. Thank you. I would say welcome back again. Welcome back again. What a terrific thing. And, to celebrate, the more you can celebrate, the more you increase this culture that we have in this college, and to highlight really some incredible faculty. So thanks for the presenters before this, on whatever that date was. It was marvelous, and I think this night will be another way to celebrate such really some wonderful things going on, and then also to connect to the community. So I want to thank Servet, the provost, for that, but also thank the faculty for everything that they do every day for our students. Our students are incredibly special. So are the faculty. So I want to thank you very, very much. Enjoy the evening. Thank you. Thank you.
Thank you, President DiCristofaro. It's all with your leadership. Now, they say the world has never been more divided. But I think Professor Kornheiser might disagree. She would say that the battle lines between science and poetry were drawn thousands of years ago. But she would also say, there is hope. It is my pleasure to introduce Professor of English and Humanities, Dr. Laurel Kornheiser. Laura earned her PhD in literature from Northeastern University. Long interested in the intersection between literature and science, she has presented at various conferences, including the British Society for Literature and Science Conference. In addition to teaching literature and writing courses at Quincy College since 2010, Dr. Kornheiser has taught poetry writing to inmates at the Plymouth County Correctional Facility and worked with probationers through the bibliotherapy program called Changing Lives Through Literature. Please welcome Dr. Kornheiser to present Science and Poetry, Frenemies.
Good evening, everyone. Thank you for coming to hear this talk. Thank you, President DiCristofaro, and thank you, Provost Yatin, for that wonderful introduction. Happy to be here with all of you tonight and to share some work that I've done recently. A colleague of mine, Debbie Saderinger, who you'll hear next time we have some speakers, and I each presented a paper at Yale University back in the fall. For the American Literary, the Association of Literary Scholars, Writers, critics and writers. I can never get that one right. There's just too many nouns all in a row there. So this is a presentation that was based on the paper that I presented at that conference. So to begin with, some of you may not have known, if you look at this word frenemies, you may not have known that there was any kind of a competition or a strained friendship between science and literature. You know, it's not the stuff of headlines, for instance. So we aren't going to find headlines like "Science accuses poetry of fake news," or "Poets call science out for pretension." So that's not anything you're going to see, you know, anywhere that you probably run into. It's probably not even on social media, for all I know. However, these are some headlines or paper topics and website headlines that I just pulled off the internet just the other day. So it's an ongoing debate, an ongoing competition, subject to conversation. Science and poetry, a view from the divide. Science, poetry, oxymoron or vital device. Verse in the universe, the scientific power of poetry. Science versus poetry. And science and poetry more similar than you think. So just from these alone, I think you can tell that this is sort of a vital conversation. So the question is, what is at stake? Why does it matter that, you know, poetry has things to say to science and about science, and science, I'm not really sure how much science pays attention to poetry, to be honest with you. I think that, I have to say, I think that the poets pay more attention to science than vice versa. And having presented at the British Society for Science and Literature, I can say that there are always far more literary people there than there are science people, outnumbered probably 3 to 1 maybe. But what's at stake are really the essentials of our existence. You know, when these two are sort of battling it out, they're trying to make claims for truth. And both of them, both fields make claims about truth about nature, existence, the way the world works, relationships, what we know, what we really don't know, even what we can't know, and the truth about reality. So each makes claims for all of those truths, actually. So when we think about science, we always think about science as somehow, you know, representing reality numerically. It's based on observation, it's based on experimentation, hypotheses that are proffered and tested and refuted or modified. I took this from the CUNY website, scientific method and the ways it gets at empirical truths. You know, when you go through this process, the truth concerning these empirical claims correspond to fact. They cohere with and are consistent with other established truths, and they have useful consequences. And I think that's one of the reasons we love science so much, is because we base our lives on science, right? Our buildings, our bridges, our medicine, our foods, everything is based on science. So we definitely want to trust our science. Shakespeare would, you know, represent the poet's eye and what the poet is able to do. So he claimed in this quote from A Midsummer Night's Dream that the poet's eye, in fine frenzy rolling, doth glance from heaven to earth, from earth to heaven, and as imagination bodies forth the forms of things unknown, the poet's pen turns them to shapes and gives to airy nothing a local habitation and a home. So in other words, the poet creates, right? Science sort of represents what's out there, and the poet, Shakespeare says, is actually pulling things that don't exist and bringing them in through their pen, you know, poet's pen, giving them some kind of shape and being. Elizabeth Barrett Browning, living in the 1800s, the Victorian age, which I'm going to talk about in just a second a little bit more, you know, she really kind of was pushing back against science because science, everybody thought science is truth. What else do we need? We have everything we need through science. It tells us all we need to know about reality. And in her poem, Aurora Leigh, she kind of goes against that, and she says, the only truth tellers now left to God, the only speakers of essential truth, opposed to relative, comparative, and temporal truths, are the poets. So the poets are getting at truths that are far deeper, wider ranging, and maybe more important, you would say, than the scientists. And I've stolen this quote from my colleague Dave Ricca, who's in the audience here. So when we were coming up with copy for this program tonight, He kind of encapsulated the way I think we sometimes think scientists think about poets,
But they don't.
But they don't think about them at all, that's right. So his quote, like a sad mime out in the rain, poets lament that they get no respect, which is why I think we hear much more from poets pushing back against science than the other way around. All the cool kids become scientists, he says. Probably true, we're all nerds, all this poetry people are probably nerds. So this divide goes back a long time. When we think about poetry, poetry's been around, as far as we know, at least 3,500 years, but probably longer. Most indigenous cultures encapsulate their history, their knowledge through poetry, orally transmitted for many, many, who knows, maybe thousands of years before it was written down. Science goes way back too, probably at least 2,500 years, if not longer. And it's almost been since both have been in the world at the same time that this back and forth between science and poetry has existed. Part of it fueled by Plato 2,500 years ago. Because Plato, kind of goes after the poets, and he says, first of all, they don't make anything material. They don't make anything useful. They don't demonstrate any practical skills. Moreover, they deal in representations and images, which he says are a considerable distance from truth. They're illusionists who cast spells with music. And therefore, he really didn't want them in his republic. He didn't think that they should be there. He thought they were kind of dangerous, which in my eyes, that just speaks to the power of poetry, that he was so afraid of poets and what they were saying. But that's me, all right? So skip ahead a couple thousand years, so the debate goes back and forth for a long time, and we see, a lot of works like this where poets write whole treatises defending poetry and the usefulness of poetry. We're not quite up to the art for art's sake, movement yet. It's like things have to be useful, and so poets have to prove that poetry is useful. So Sir Philip Sidney, writing in the mid-Renaissance, talks about the natural philosophers, which is what scientists were called until the 19th century, and mathematicians, and he says they have the works of nature for their principal object, while only the poet, disdaining to be tied to any such subjugation, lifted up with the vigor of his own invention, doth grow and effect into another nature, in making things either better than nature bringeth forth, or quite anew, forms such as never were in nature. So in other words, the poet is a creator. This is also what Shakespeare was saying, right? Poets create something brand new. Scientists, I'm not going to say merely, scientists represent what is, what's already here. So the creator versus the describer, maybe. That's Sir Philip Sidney saying that. So this really heats up when the age of science comes into the fold, which starts sort of in the Renaissance with Copernicus, Galileo, and then we get into Newton, and then in the 19th century into Charles Darwin, and suddenly science is informing everyone's lives, and it's everywhere visible, and it's being heralded as, the way to understand our world and reality. And rightfully so. When we think about all of the things that arose in the 1800s because of the age of reason, the age of the Enlightenment, also known as the age of science. There are so many things that emerged that were impacting everybody's life everywhere you looked. And so, we had obviously all the things of the Industrial Revolution, all the machines, the steam engines, factories, trains, paleontology, germ theory, the periodic table, all came from that one period, and this is when the natural philosophers become scientists, and the field gets codified as a discipline. So of course we have pushback against that, right? The claims were that all you needed was reason and rationality to understand our world. That's it. So the Romantics come along. These are, it's really an aesthetic movement, it's an art movement, a literary movement, and they're pushing back against this immediately because they feel like we are more than just rationality, that a whole aspect of our mind and our understanding is imaginative. They also resent the subjugation of nature to science's peering eyes, and I'm using some vocabulary from two of these poets, that science, doesn't have enough of a big picture in what it's doing sometimes, that it's peering too deeply into things at a cost. And so William Wordsworth, who's one of the great Romantic poets, this is from his poem, The Tables Turn. He says, "One impulse from a vernal wood may teach you more of man, of moral evil and of good, than all the sages can." Sweet is the lure which nature brings. Our meddling intellect misshapes the beauteous forms of things. We murder to dissect. So this is pretty much the Romantic major charge against the scientists, is that in the course of their investigations, they kill what they are looking at or what they're finding out about, and there are consequences that they're not always aware of. Edgar Allan Poe, to come on this side of the pond, has something similar to say in Sonnet to Science. And Edgar Allan Poe actually was very interested in science. He read a lot of science, wrote science fiction. And he writes, "Science, true daughter of old time thou art, who alterest all things with thy peering eyes. Why preyest thou thus upon the poet's heart? Vulture, whose wings are dull realities." I'll let that speak for itself. So then a curious twist happens pretty early on, though. Once Darwin comes up with his theories, and we understand that there's this, it's called a mechanism of natural selection. Now scientists are getting into realms that cannot be observed, cannot be directly experimented upon, are hypothesized, theorized, maybe inferred from other things. And so, interestingly, the scientists start turning to the poet's tool of metaphor. And so we'll talk about that a little bit. But I also want to make the point that science is also an imaginative act. And that's something that sometimes I think poets and people that think about this, people that study science studies, want to make sure we remember this, that science is an imaginative act. That before you can send a man to the moon, you have to imagine doing that. And then the science to achieve that is created, right? Before you can build a skyscraper, you have to imagine the skyscraper first, and then you find the science a lot of times. So a lot of times the material reality that comes out of science is in the imagination before the science exists to bring it into creation. So this is a quote from Aaron Grintner about metaphors in science. There are innumerable examples in the history of science wherein a rudimentary idea was first represented by some metaphorical expression, and then, through research and rationalization, was brought into concrete existence. Every exploration begins with a creative inclination, demonstrating that all creative processes, such as metaphors, underlie all structures of scientific research. That's a huge claim there, that metaphors are the foundation of all of these. I'm not sure that I would go that far, but I think someone who's studied that can make that kind of a statement. I think it's very interesting. So when we think about typical metaphors in science, they're used for two reasons. First of all, science needs to communicate what it finds to the public. And especially in democratic societies where a lot of decisions are made that interact with either our environment, our health, that impact us in all different ways, we need to understand the science behind these things. And so metaphors come in handy for explaining science to the lay public. But we'll find, too, that metaphors are used within the scientific field itself. So metaphors such as waves, right, sound waves, that's based on ocean waves. What is this like? It's like sound waves. We talk about the mechanism of natural selection, right? That is a metaphor. Genetic blueprints, carbon footprints. So if you look at the language of science, you see that metaphors are sprinkled everywhere. So they're already there. But sometimes they can be misunderstood, right? So you have to be careful, especially when science is conveyed to the public, that metaphors are not misunderstood, either on purpose or by accident. And this came up with the mRNA vaccines. And M is a metaphor. This is messenger RNA, right? So that's a metaphor. And it just, it has a role in carrying protein information to the cytoplasm, where it can, sort of say, please make this kind of protein, and then triggering our body's immune response. That's how the mRNA works in a nutshell. But obviously we know that this was misunderstood in a lot of situations. People in the public thought that that meant that our DNA was being altered, right? Or the vaccine codes you somehow, right? We use this language of computers all the time, especially in genetics. And so people started becoming suspicious of it for that reason. People thought that the vaccine was going to inject microchips into everybody, and I found out that was one guy kind of blew it up on social media, someone named Charlemagne, who had heard that Bill Gates wanted to, you know, it was some kind of like a tattoo, something that they were going to be encoded with our vaccine card, so we didn't have to walk around with a card. We would somehow have some kind of a digital card inside of us or something to prove we had been vaccinated. And so suddenly that became, oh my God, Bill Gates wants everybody to have chips inside of them so they can be tracked forever, right? So this is when it's a dangerous thing to use metaphors. Metaphors are helpful because they are a little bit fluid, because they create analogies so we can understand things, but they can also blur lines and they can be ambiguous, and that can create problems. This also happens within the scientific community. I'm not going to go through all of this in the interest of time, but particularly with genes. When we talk about genes encoding and, you know, genes as code and as encoders, that was found to be misleading because it was like the unit thing was also the agent at the same time, and so the narrative around that was a problem, and the idea of a gene agent was a problem, that it was somehow misrepresenting the information, and so that language has changed to genome, which is considered like a blueprint, and it also becomes problematic sometimes. It was limiting, you know, Evelyn Fox Keller, the physicist I mentioned earlier, talks a lot about how that language limited what people were looking for. One particular area where that's true is with what they called junk DNA for a while. There was all this stuff, they're like, that's just junk DNA. And so people didn't look there for anything. If you call something junk, if that's your metaphor, they're like, okay, that's worthless. We don't need to look there for anything. And then over time, they realized this was very significant. There was something else going on in there that needed to be attended to. And so now we call it the dark matter of the genome, which, I don't know, dark matter also sounds a little scary, I don't know, but I don't know if it's any better, right? So, you know, but again, it's this idea that, you know, if you name something, if you use a metaphor for something, that might limit someone's thinking. That might keep, you know, if one scientist uses it and it keeps getting passed down, then people might not look outside of that box, and that can be a problem. So even within the scientific field, metaphors can be a problem. So not only does science use metaphors, but some poets use science as metaphor. So this is one of my favorite poets, Kay Ryan. She was the Poet Laureate of the United States about 10, 12, 15 years ago. And she's got a lot of poems that engage with science, but she uses it as a metaphor. She's not using it as her subject. She's using it as an analogy to show us something about our crazy human existence. And she was quoted at one point saying, I feel like science and I are making a picture from opposite sides. So she recognized and wanted us to recognize what she was doing. So here's a little bit of one poem called Intention. Sometimes only hours separate the cotyledons from the wooden plant. Then if you want to eat it, you can't. So it's like that idea that act on your intentions, right? If you wait too long, it's only a slight moment sometimes between intending something and the whole thing being untenable for some reason, right? So she's using a little bit of botany in there. This is against gravity, so here we have some physics. How do we move under weight? What opposite force do we generate that keeps our clothes floating around us, for instance, or goes any distance toward explaining our fondness for jumping? Some pump, like a fish tank's maybe, some auto-aeration or something, because we're glad some mornings and buoyant as though we had no bombs or appointments. I could talk about that poem for an hour, which I'm not going to do. So just suffice it to say it's out there. You can go back and read it some more. So here's one more, Any Morning. Again, this is a poem that's kind of talking about what happens when you get up in the morning. Everything seems to be going normally, and next thing you know, it all falls apart somehow. You get into a fight with your significant other, or everything just gets to be in shambles as you're trying to get out the door. So she says, any morning can turn molten without warning. Every object can grow fluent. Suddenly the kitchen has a sulfur river through it. There is a burping from the closet, a release of caustic gases from the orange juice glasses. The large appliances are bonding in a way that isn't pleasant on linoleum as friable as bacon. We never fathom how we caused it, or why we never see it coming, like Hawaii. So I don't know if that ending's supposed to be, wow, that's a beautiful thing that comes out of all that mess, or if it's like, wow, things can really get disrupted, and suddenly you've got a whole volcanic island that comes forth from the ocean. So the second poet I'm going to talk about, last poet I'm going to talk about is Marianne Moore, and she's considered the most scientific of modernist poets. She was very, very interested in science. She was a political science major in college, but she was always interested in biology and had hundreds and hundreds and hundreds of books on biology. And so she makes the statement that precision, economy of statement, logic employed to ends that are disinterested, drawing and identifying, liberate, at least have some bearing on the imagination. So that language she's using at the beginning is sort of like what we think about with scientific statements, right? Precision, economy of statement, logic. And then she kind of gets a little slippery toward the end of that quote, like she always does. So these are just a few of her titles. I'm not going to read them all, but you can see she's very interested in, the fauna and flora. These are mostly the animal and sea life kinds of characters that she looks at through her poems. So I'm going to look at one poem, even though she has all these poems about, pangolins and nautilus and all these other things. She's got this poem, An Octopus, which isn't actually about an octopus at all. It's about Mount Rainier and the glacier at the top of Mount Rainier, and she thought it looked like an octopus. And so she's got this poem, and it's a long poem. It's a 100-something line poem. Would you like me to read it? So anyway, it's a very long poem, and I'm just going to give you a couple of little snippets out of this poem. So the poem is like a mountain in some ways. So a mountain is a composite of its plants, of its animals, of its rocks, of its processes. And this poem, too, is a composite. This poet is very famous for making collage poems. She didn't think anything about borrowing something from a telephone book or an ad or a brochure and putting it into her poem. So what she does with this poem is she constructs this mountain of over 100 lines, is she shows us how we really draw from all kinds of sources for anything we know. So she uses guidebooks, she uses scientific language, she uses an advertising brochure, she uses description from when she had been at the mountain. It's a really interesting composite of all different styles and a mesh of different sources. So these are a couple of lines that show you what she does with this kind of stuff. She calls that glacier deceptively reserved and flat, lying beneath a sea of shifting snow dunes, comprising 28 ice fields from 50 to 500 feet thick. So she gets precise and not at times, right? She says it's python-like and it's killing, it hovers spider-like, and then she gets a little more scientific when she says that it's stained transversely by iron where the water drips down. She also goes through animals. Some of them are anthropomorphized, some are not, so exacting porcupines, but then when she's starting to talk about the antelope, she has a whole little composite of styles there when she talks about the antelope. Very typical of what she does in this poem. And even the physical and biological processes, she's rendering the idea that this mountain is always in process, that almost like knowledge, it's not stable, that all these things are going on under the surface, almost like Kay Ryan's Hawaii. We're going to get a little bit of foreshadowing that this thing is going to erupt. So at one point she says the mountain's cone-like top is reminiscent of Mount Fujiyama's until an explosion blew it off. And this is exactly what she has happen at the end of her poem. An avalanche comes and cuts down the glacier a bit, and she has to use a simile to say what it's like, and a metaphor and a simile in that last line, and a curtain of powdered snow launched like a waterfall. So there's an avalanche. So what is she up to in this poem? Oh, sorry, before I go to that. Just like science has to be careful when it uses metaphors, poets have to be careful when they are using science, because they'll get called out. So there's one critic who says she doesn't like this poem because she feels like Moore she's using scientific detachment. She's foregrounding biological and geological activity, that she's complicit with science objective knowledge, even though it's instrumental in concealing while enacting the privileges of power. So one critic is saying she's being too scientific, and she's actually a feminist critic. She wants to hear Marianne Moore talk about the mountain more in feminist terms. And another one says that she's not being accurate enough. Says, hey, if you're going to bring science into a poem, you better make sure your science is right. Because at one point, I think Moore puts a tree at the wrong height or something. And she says that, poetry's role is to teach us to attend to what we perceive and to trust the words we use to articulate our perceptions. So poets have to be careful with what they do in science. And so my perspective on this poem is that she's really showing that all of our knowledge is by accretion, that we really, everything we think is a product of historical writings, things we've read, things we've seen, things we've heard said, things we've been taught. Is there any such thing as original knowledge? So just look, and she also says science is never finished, that science can be overturned. What we think one day and base our reality on one day can be changed. So just to finish up, the question is there any such thing as unfallen, unmediated knowledge, whether it's scientific or poetic? And Marianne Moore would say you have to be Adam before Eve showed up to have that relationship with the world, an original relationship with the world. Because otherwise, everything is mediated through others. And so in the end, poetry and science, frenemies, they're friends and enemies, but this is my view. So through science, we marvel at the intricacies, expansiveness, patterns, and processes of our world, and we enjoy all the benefits of its applications. And poetry, through poetry, we marvel at the intricacies, expansiveness, patterns, and processes of our world, and we enjoy the benefits of its art. So metaphors and imagination together bridge science and poetry. So anyone has comments, questions, thoughts? Yes, Dean Carroll.
So it's not a question.
Okay.
As you were speaking, it occurred to me that scientists really have nothing else at their disposal than metaphor, right? Because they're, especially if they're observing something brand new, right? So the only thing they have to talk about it is relying on waves or, these other words. I don't know.
Right, and I think there are some people that feel like science doesn't admit how much it relies on metaphor and metaphorical language. But analogies are always slippery. Yeah, you're absolutely right. Yep. Dave, you had?
Yeah, I was going to say something similar. The best scientists are good at getting across ideas, and usually that involves something poetic. Schrodinger's cat, that whole idea.
Right.
That
yeah.
can't be explained in a way that isn't metaphorical.
Right, and again, that's why I think it really explodes during the time when genetics come into play, and trying to figure out evolution and the mechanisms of that. I'm using the word mechanism alone.
There you go. Yeah.
There's a metaphor,
Yeah.
right? So yeah, how do you say it without using metaphor?
Yeah,
Right.
How do you communicate?
Yeah, exactly.
Okay.
Yeah, thank you.
Oh, sorry about that.
Any other questions or thoughts?
I was curious, when you talk about the relationship between science and poetry, you hear that expression, poetic license. Is that meant to be an insult or a compliment?
Poetic license implies that you're allowed to use your imagination to get at a truth. So you're not sort of tied or tethered to exactness, which is what Marianne Moore is doing in that poem that I was talking about. She's playing loose with certain things. She's being accurate with some things, playing loose with other things, and she knows she's doing it. But part of it is to get at a greater truth beyond that. So poetic license allows you to play fast with the facts if it means you're getting at a higher truth in some way.
Do you happen to know, this might be an unfair question, but when that expression came into use?
I don't. I wish Steve Dooner were here because he probably knows. Do you know, Debbie? Does
Might
anybody
be an
know?
interesting moment.
Yeah, no, I don't know.
I'm
Yeah.
done.
Okay. I think we have a question for you.
Well, it's always fascinated me that science fiction, they take science and they use their imagination, and they have made scientific discoveries through watching and thinking about science fiction, which is using your imagination.
100%. And, I teach certain stories. Like I taught one recently by Ray Bradbury called The Veldt, written in 1950. And it involves a virtual room. It involves virtual reality and some kids who are like the kids today that don't want to be told they can't play video games 8 hours a day. And the parents are like, you can't spend all day in that virtual room. And so the kids who can, because they know more than the parents do of technology always, right? And so the kids end up using the African veldt, which is like the savanna area, and create lions, and then when the parents are going to shut them out of the room, they shut the parents in the room instead, and I hate to say the lions eat the parents, but it is Ray Bradbury, exactly. Yeah, 1950. Right, yeah, so many of his stories. So he anticipates virtual reality, and people are using those goggles these days to go through these virtual experiences, and there he was writing about it over 70 years ago. And there are a lot of science fiction writers, the things that they were writing about 100 years ago are reality now. And I like that because it kind of blows my students away a little bit, because sometimes they think anything that was written more than 5 years ago is ancient history. So it's cool to be able to share that with them. So, yeah, yes?
I just feel that, well, what you're saying is really incisive, because I feel that people back then, in the ancients, they tended to be more, they used to express things more poetically. So even scientific truths can be expressed poetically.
Right.
Whereas these days, if it's poetry, it's not science. If it's, if it's science, it's not poetry. It's, but they're actually the two sides of the same coin. But people back then were more integrated. They were able to embrace these things. So I feel like these days, we tend to be a little bit more compartmentalized.
Yes.
Either this or that. It sort of speaks to like a certain kind of divisiveness that we have in society as well. They're two sides of the same coin. They're kind of like the yin and yang. But we just sort of like are more separated these days. We sort of that's that and that's something else. So I feel that this is great, and people should maybe realize that a little bit more.
No, I love what you're saying so much, because some of the earliest science was actually written in verse.
Right.
Like the times of Plato, Socrates, that was when science was written in verse, and for quite a while. And interestingly, another writer, Ralph Waldo Emerson, who I quoted at one point when he says perception is fatal, meaning that whatever you expect to see, you're going to see. So even with science, if you have a hypothesis and expect to see certain things, you have to be careful that you're not becoming a self-fulfilling prophecy. But he, in 1830, was worried about all the compartmentalized, way that society was becoming, that, industry, you do this job and you have this piece, and you do this job, you have this piece. And so it's exactly what you're speaking about, that, it became sort of disintegrated rather than integrated, and knowledge fields become so specialized. And sometimes that cross-fertilization is what really gives rise to amazing insights, right? So, thank you very much.
Thank you, Dr. Kornheiser. I'm impressed with your vocabulary. An English and Humanities faculty member having such a scientific vocabulary happens only at Quincy College. We'll just change the slides. All right. It seems that every day another study comes out with nutritional advice. How do we know what is true? We are very fortunate that someone at Quincy College has the expertise to untangle the complex web of nutritional and genetic research. It is my pleasure to introduce Dr. Poorna Mukherjee. Prior to joining a research lab at the Dana-Farber Cancer Institute, Poorna earned a PhD with her work on cancer chemoprevention in India. Currently, she is a research faculty member in the Department of Biology at Boston College and teaches as an adjunct faculty at Quincy College. Please welcome Dr. Poorna Mukherjee to present Cancer, Bad Genes or Bad Diet. You decide.
Ready? Thank you. Thank you, Dr. Yeti, Mr. President, my co-worker who helped fix the title. I'm really bad at that, anyway. And if I go over, just stop me. So, yeah, so let's, well, it's not changing. If you all know, I don't need to define what is cancer. I don't need to define what's mutation. If anyone, any day, we can get this disease, you go to the hospital, you have to go biopsy, you have this mutation, you have that mutation. Pharmaceutical company, they're ready to give you drug. If you're lucky, you'll find, but you know, where we are with the cancer every day, 1,600 people are dying in this country. But nothing against, we are doing science. That's why we are here, and again, better to, sometimes feel better to do poetry, not science, like it's so frustrating. This paper, Hallmarks of Cancer, the Next Generation, Dr. Weinberg and Dr. Hanahan from MIT, they published 2011, and it's a landmark paper and cited 5,000 times by other authors. So, what they said, they said, cancer cells carry the oncogene. So, you know, or who doesn't know, mutation in your nucleus. And if any changes in DNA that can, if your tumor suppressor gene off or oncogene on, and that will give you cancer. That's the dogma. Last 40 years, 50 years, we are working on this. Okay, so if that is a dogma, why do you think cancer is not a, so is that all the mutation? You go for screening, genome, is that all hallucination? No. They are there. So where is the problem? Why is not working? Why is still palliative? Why I get cancer and I get panic? So, we are saying, it's not we, I'll go back to that slide, it's from 19, it's not kind of suppressed. This is, problem is not in the nucleus. Problem is in the mitochondria. Mitochondria, again, go back to your high school biology, that's your powerhouse of the cell. Who generates ATP, energy, right? Now, how the mitochondrial problem upregulates all this mutation that you can see on the screen, right? Let me talk about your normal cells, who just review. Okay, so this is when you eat, everything turns into glucose. Whatever you're eating, it has to be glucose. Glucose is an easy molecule in your blood, abundant. Window is from 80 to 120 mg per kg, right? That's the first step. When you go, glucose enters, you don't need to remember all that, just to review it. Pyruvate, and this is the mitochondria, the yellow structure, where you generate your ATP. But there are 3 steps. First step is the glycolysis. Second step is the TCA cycle, Krebs cycle. Only you generate 5% ATP. So where the majority of the ATP is coming from, that's called cellular respiration, where you need oxygen to burn the glucose. Electron transport chain, oxidative phosphorylation, it's all same. So there's a complex, everyone knows who is in from biochemistry, how you generate 90% from here. That's your normal cells. In cancer cells, we are saying most of the ATP is coming from these 2 steps, that's damaged. Electron transport chain, complex 1, 2, 3, 4, 5, who knows, that's some problem there. Because it's a very quick, and what's happening for the cancer cells, you go the glucose, everything goes to lactate. That's known. That's known, scientists are accepting that highly glycolytic. All cancer cells proliferate like crazy,
and they are highly dependent on glucose, and they produce lactate. Even you don't have oxygen, because glycolysis you don't need oxygen, so you produce lactate. Like when you're doing a lot of exercise, you generate lactate in your muscles because you're deficient in oxygen. So cancer cell can live in hypoxic condition. So that's lactate is called fermentation, like bacteria. Fermentation, you ferment what? Ferment glucose to produce lactate. And that's known. That's not, we are saying something new. What we are saying new, the second one, so that means you're saying cancer cells love glucose. Of course. That's their only food. What do you do for your PET scan? Tracer glucose, FDG uptake. Why do they do FDG uptake? Why not fatty acid uptake? Because cancer cells love glucose, like there is no tomorrow. So you just put in the tracer and doing your PET scan. Ooh, look, all white things. That's my tumor. That's my tumor, right? They know. But how can you target glucose? It's hard. This is your another one we figured out. It's not we again, the group of scientists that are working on metabolism, glutamine. So the painful thing is glucose and glutamine, these are the two major fuels for the cancer cells, but the two more abundant molecules in your blood. Glutamine is everywhere. Your gut needs glutamine. It's an amino acid. Glutamine is an amino acid. It's a building block for proteins. That's in your muscle. That's for your immune cells. But cancer cells also love that. Now, if that is the case, if this is kind of damaged and you are generating, you are basically glucose and glutamine, that's a nice word, fermentation. You don't need oxygen. So cancer cells ferment. What do they ferment? Glucose and glutamine. Okay. Yes. It's not new. Warburg, German scientist, 1956, that's the Warburg theory of cancer. He said that cancer cells continue to ferment glucose to produce lactate, that time without anything, just a microscope, few tissues, and cancer arises from damage to cellular respiration. He used that word. Only thing he was missing, he didn't know about glutamine at that time. So, basically, cancer cells ferment. My message from the few slides, cancer cells ferment glucose and glutamine. Glucose is from food, glutamine also from your food, you eat meats and all that. But what's next? Understand? Those are the two major fuel. Little bit more. Every cancer cells has damaged mitochondria. What you see here, this is a nice normal mitochondria. It's called cristae. Double inner membrane, cristae structure, where that number 3 electron transport chain, also enzymes are sitting here. So structure, that's a diagram. That is electron microscopy. That's for cancer. GBM is a brain tumor, but every tumor has defective mitochondria. Cristae structure. Structure determines function. How come with this mitochondria they should have a normal respiration? Not. So that's a fight with us now. So 90% scientists from everywhere, top scientists, they're saying no, their oxidative phosphorylation is okay. Few of us just saying no. Okay? It's a big, big fight. Now, it's a cartoon picture. It's not just to draw it. It's from all paper. All the papers that developmental scientists, mostly not cancer scientists, did so many years, it's just you have to study, read. People have no time to read them. They want another grant or they want another position. They are just narrow. If you read all this paper and if you connect the dot and draw this picture, this is, think about the green cells, your normal cells. This is the nucleus and tiny, tiny mitochondria. Red one is the cancer cells. That's their nucleus and that's their mitochondria. So normally, normal cells will give normal cells and tumor cells will generate tumor cells, right? Now, this is called nuclear transfer experiment. If you transfer this nucleus to the normal cells, if you have a problem with the mutation in the nucleus, then it should not be a normal cells. That will give you the cancer cells. Same thing for the tumor cytoplasm. If you bring the normal nucleus, you still get tumor cells. So problem is not in the nucleus. Problem is in somewhere else. Some people before they said it's in the cytoplasm, it's actually in the powerhouse. How they generate energy, how they're fermenting. So that's the thing. You can do the other way, people are doing it, mitochondrial transfer. This is nuclear transfer. You can do the mitochondrial transfer experiment. So if mutations are not the origin of cancer, then how the cancer cells get all this mutation, right? Okay, so next slide is little complicated, but I'm going to explain. Don't look at it. Don't look at it. That's all in this book, but I'll make it easy. So just look here. This is the mitochondria. Think about it. This is the mitochondria. That's the nucleus. What happened? You know, cancer is not overnight. I eat something, tomorrow I get cancer. No, it's a chronic disease. Either some carcinogens, or radiation, hypoxia, inflammation, oncogene, virus, age, anything that will slowly, chronically will damage your mitochondria. At the same time, you reduce your OXPHOS respiration, and you increase your fermentation. Slow process. And this is called too much retrograde signaling. You don't need to know all this. Reactive oxygen species generation, that signal goes to nucleus. And then by default mechanism, everything upregulate, which you see all highly angiogenic, anti-apoptotic, you don't know all this yet. Anyways, all these hallmarks of cancer. And you see the mutation, but mutation is not the cause. Problem is here. What they're trying to do, oh, I'm trying to give you a GF receptor inhibitor drug. That's not going to work. That's not going to work. Because your problem is here. Problem is not in the nucleus. How do you know further? So if all cancer is a mitochondrial metabolic disease, what should you do? At least they have something. What kind of therapy do you think can affect the cancer? Of course, is a glucose and glutamine hog. So first, as I said, if you think the cancer cells are eating glucose and glutamine, and one molecule in your body, I don't know if you know that or not, that's called ketones. Ketones you have very low level in your body, 0 point something. But if you go for fasting or dieting, caloric restriction, your ketone level goes up. Why? Because your normal cells now switch from glucose to ketones. Cancer cells damage mitochondria cannot ferment ketones, cannot ferment fatty acids. They can only ferment glucose and glutamine. But normal cells also need glucose. Why not you flip from glucose to ketones? So ketones, if you keep it in the physiological, you cannot go pathological unless your ketoacidosis with the diabetes. Ketosis condition is always good. Now, if you can go for increase the ketone level, decrease the glucose level, can you manage the disease? We don't know. Let's see. So any therapy that can reduce your blood glucose and glutamine, glutamine is there, and elevates blood ketone at physiological level should kill tumor cells and keep normal cells healthy. Okay? What are the mode? What are the different ways I can reduce the blood glucose? Of course, if you don't eat, how is possible? I have a cancer, I will not eat. Caloric restriction, fasting, ketogenic diet, you know, it's a high fat, 0 carbs, protein diet. There is a ratio. I'm not a nutritionist. I'm just telling you, this is the way. I'm a researcher, but there are some nutritionists now tagged. Ketone ester maybe. What about the glucose? How can you reduce the glucose? If you do not, these are all drugs. Metformin is for diabetes, insulin, 2-deoxyglucose, better to avoid if you can manage with the diet. That's because our approach is a non-toxic way. Toxicity of chemo, if you really need it, different issue, is a very personal. You understand now. Dana-Farber will not like it. But it's a very personal thing, depends on your situation. If you have a weight watch time, before you go for another scan, Why not? Try it. So that's caloric restriction. I did a lot of work last 20 years on mice with cancer, published. Whenever I did caloric restriction study, people think it's a starvation study. Like if you don't eat one meal, that means you're starving. That's not the case. And this differs from starvation. Oh, I sleep like 8 hours in the night, I miss one meal. That's killer. That's the killer. It maintains minerals and vitamins. It enhances mitochondrial biogenesis. People know who are really health conscious, they go for that periodically. But cancer, we have to think about how to modify. Now, again, normal blood glucose, this is the glucose, that side is the ketone. So the black line, 8 millimolar, if you reduce to say around 3, which is hard, but it's possible, and if you, at the same time, you don't need to increase ketone. When you reduce glucose normally, ketone goes up. And ketone goes, this is the area where you can manage the growth. So this is the fun, this is the basis. Now, did it work in the preclinical study? Yes. Yes. This is just 3 figures. I didn't have all the papers. I cannot say all this. Just one example. AL means this mouse is eating high chow food that usually in animal facility gets supplied. So, and this is the caloric restricted group. And you can see the significant reduction of the brain tumor growth in the B6 mice. Now, then I have another model. This is highly metastatic. You tag with luciferin gene, and you can see again high fat, they're going everywhere. Liver, spleen, lungs, kidneys, and with the ketogenic diet study, significant reduction. These are all published, and when you're doing this, question comes and published and also review and media. Now the patients are coming, email, phone call. Can you go for ketogenic diet? So is that working or not? First study, she is Nibelling case report. It is a long time ago, and that's the first one we attracted, like 15, 16 years old. And she was studying nursing or doing PhD at Cleveland Clinic, and she published that. And you can read the whole thing. Ketogenic diet reduced the blood glucose and increased the ketones and managed the 2 children's brain tumor. Doctors just give up. We cannot do much. So she said, why not I just do it? Let's see if we can manage it. So that's the first study. And then it's non-follow-up. She moved to NIH, and we're just reading that paper. Oh yeah, it makes sense. So let's do more. This is our first case study from Italy. The woman got brain cancer, and the funny thing is her son is a radiation oncologist. He doesn't want to radiate mom's brain. And we start laughing. Really? You want to radiate all your patients, but not your mom's brain? Why? Don't you think it works? Yeah. So he said, just between you and me. Okay. And actually, I can tell now he's open. He's in Pittsburgh, UPMC Medical School, Dr. Zulpuli. And she got brain tumor, but she was with the radiation and chemo, and on the top of that, the diet. But it's remarkably, I have still that email, like, she has no tumor, we couldn't find anything brain tumor, which is very unusual, but for some reason she went back again, and they gave devastating some kind of thing. You can see, that's the tumor there, MRI contrast enhanced, here after ketogenic diet and standard therapy, and she was kind of get rid of that tumor from the brain. For brain tumor, this is challenging. So what we are saying, standard of care, for especially for the brain tumor, look here, what do they do? First thing, radiation. Radiation break your glucose glutamine cycle between neuron and astrocytes in the brain is a tight cycle. You cannot disturb that. Radiation break that, release all the glutamine. Then what do they do? Steroid. Steroid induced hyperglycemia. Glucose is on the roof. So you're releasing glutamine, you're releasing glucose, what else you need for the tumor cells to grow? Need to stop this. And only one drug, temozolomide, I don't know if you know that or not, Last 50 years they didn't change because of the blood-brain barrier. There is no new drug, so they're same thing. No improvement. Maximum 2 years survival. That's the Stapp et al. This is a guru of radiation, even brain tumor surgeon. You can see the survival curve. This is 50% death in 1.5 years. And you all know that when you get GBM, glioblastoma multiforme, is no hope. And they tried their best. Okay, that is the case. Our next question, provocative question, should be the first hand of therapy. Should ketogenic metabolic therapy become the standard of care class, not radiation and chemo? So that came out, and that's really disturbing for the whole field. Brittany, she was on the People magazine cover. She got brain tumor, 2014, and she took her life January 2014, November. Look at the steroid effect of the face. Yeah. She took her life. She went to Oregon, only state that you can do that in the presence of mom and husband. She took her life. On the other hand, Pablo Kelly from England, same year he was diagnosed with a brain tumor, still surviving, and he refused chemo and radiation, and we published that. Ketogenic metabolic therapy without chemo or radiation for the long-term management of glioblastoma. He got married, he was 24 years old, and he got married, 2 kids, happy. And when we talk about that with Stapp, someone emailed to Stapp, what do you think? He said it's just a fluke. Yes, true. We need more flukes. We need more flukes. He's right, it is fluke. So, you know how he maintains? Every day he used to measure his blood glucose and ketones. And that's called glucose ketone index. And that's in the paper. You can see if you think about glucose 3 millimolar and ketone 3 millimolar, your GKI, glucose ketone index, is 1 ratio. And that's perfect. No tumor cells can survive. That's perfect. And your normal cells are happy with the ketones. Second case report, I don't want to, I have to go fast now. 24-month follow-up, she is fine. Next study with the breast cancer, not just brain. Then look here, is everything gone? Then we did a lung cancer, same response, and this is all the list that's on the paper. And the last one that we are going to publish is accepted. Resolution of malignant canine mast cell tumor using ketogenic in dog. In dog. So the parents didn't want a non-still big tumor. Mast cell tumor is very common in dog. So the vet said, you have to euthanize. She said, no, okay, I'll do. Before that, I'll try. Email us, read us, everything. And she chose to go for ketogenic diet. But you can read that, she is like raw chicken. Wolves never evolved to eat those Stop and Shop aisle food, high-corn food. They're not. Give their original food. Chimpanzee never get cancer. They are 100% similar with us, 99% genetically. They have BRCA1 gene. Why chimpanzee not get cancer, we get cancer? Because what do they eat? Throw some McDonald's and that soda in their cage, you cannot do that. That's unethical. If you throw that and wait for 5 years, look the chimpanzee's breast cancer rate. These are all same. Like I have BRCA1 gene, I'm not getting cancer, another is BRCA. So BRCA1 means nothing. Mutation means nothing. Problem is, if with my BRCA1 gene, with my diet lifestyle, if I damage my mitochondria, I will get cancer. She with the BRCA1 gene with a huge good diet and lifestyle, she will not get cancer because you are not damaging your mitochondria. It's not 100% penetrance. Same for your hereditary. My mother has breast cancer, I will get, you may not. Like Angelina Jolie, took everything out, breast out, ovary out, because mother has. I doubt. Think about, she maintains her figures, everything. I don't think she eats a lot of carbohydrate diet every day. She wouldn't need to. She was fearful, like I have to take it out because my mother had cancer. So that's the summary. Preclinical case report study indicate that ketogenic diet, don't worry about restricted, and effective metabolic therapy, And therapeutic effects of ketogenic diet against brain cancer can be okay. Now, I didn't talk about glutamine. That's okay, another day. You need drug. Glutamine is drug, but should I eat meat because that has glutamine? Yes. That not change. That's need drug because glutamine receptor inhibitor or glutamine utilization in the cells. There are lots now underway, but they are giving so high dose. And my recent paper came out with the drug. We don't know. It was working fine. If they stop it for some reason. So very tricky with the pharmaceutical company. You cannot make money. It's already working fine. And they took it out, and now we are getting from China. We are getting from China. They said, yeah, it's available here. Bring it here because some patient want it. They want to live. Cancer is not a genetic disease. Cancer is a mitochondrial metabolic disease.
Well, you know, in our society, if we keep our mitochondria healthy, we won't get cancer. Very rare, just like the chimpanzee. But we're confronted with delicious foods that may not be so healthy. The food industry has gone to tweak every molecule in the food that we eat, sensitizes the taste bud to make us want this. So our brains are glucose addicted. So sugar doesn't cause cancer, but sugar can cause systemic inflammation. And inflammation damages respiration, and damaged respiration is the origin of cancer. It's almost.
Thank you. I'm from Boston College. So I worked with this old guy for 20 years, and I think we'll achieve something very soon because it's not just here, all over the world, and they translate his book in China, in Norway, in New Zealand, in Australia, and they're getting amazing results. They are trying to establish metabolic clinic, and we are just looking all the patients, whatever, and no one, how come we cannot do clinical trial? Yeah, they are doing clinical trials wrong way. They are doing standard of radiation. Can you believe it? You are making like a mess in the brain with the radiation and all that. Now you're saying the diet gonna cure this? Why don't you start first that like Pablo? Start with the diet first and see if it's working or not, then go for, okay, it's not working, I'm going for radiation. It's gonna work. They're afraid. And their license will not allow. For some reason, I don't want to say, I needed to go to that apartment, not for myself, for someone. And I met, and they just pat my oncologist, big guy, I'm not gonna tell name, just pat my back, said, I wish you success, but I cannot do it here. I cannot, that's my salary depends on it. Of course. Thank you. Thank you, everyone. Oh, sorry. I need my water. Yes, any question? Any question?
Somebody over there had a question? My question is, are there any large-scale studies that have been done, either on people or on animals?
NIH is doing that, because so much pressure is coming from Boston College, they cannot just say, otherwise they could stab us. Pharmaceutical company, or if it's like 20 years ago, we are not here. In the parking lot, you can see our dead bodies.
Oh.
But they are trying to, NIH is doing it. You can try it, you can see clinical trial ketogenic, but what's the control? We are saying what control you are doing. You are doing the standard of care, high dose of temozolomide, high dose of radiation, and you are just giving the nutrition. You know, every cancer patient has a nutritionist on the side. And they said, yeah, use less glucose, don't drink soda, don't do this. That's not the way. You have to keep that diet as a medicine.
Yeah, what's sample sizes, would you say, roughly?
I would say 20.
20 individuals?
Yeah.
Okay.
Yes, compliance issue.
Okay.
Not everyone wants to go. It will take time, Dave. It will take time. That's why I depended on case report.
Yeah.
It has to go individual, case report, reports on dog, not mouse, human, and just do that, then it will come. It has to come from the patient population, not from the top. They will never.
Are there any large-scale animal studies?
Mouse? Mouse, we're doing it. Animal means mouse. And some, dog. Yeah, mouse studies is there. It's there.
All right.
Not just us, everyone is doing that.
Okay.
I think we should stop science now, mouse now, rather go to human. They are dying. There's no time left. We will do another 50 years mouse study? No. We want to say in my lifetime, not many.
I just want to ask exactly what, just simply, what would the diet, be to help you to not get cancer or?
Prevention, good prevention. I'm telling you, again, if you know the concept, like definitely not glucose. If you get cancer, different story, how to prevent it. Because all the time patients coming, we need to send to some people. Some of the books are there. Dr. Kalamian, she's a nutritionist. She's also doing a lot of follow-up publishing on that. And for the prevention, if you do like definitely glucose cut down, and if you can time to time measure the glucose, periodical fasting, intermittent fasting, raise your ketone level high. We are not sure the ketone ester. Dr. Dominic from University of South Florida, he himself on a ketone guru, he does that. I think that's going to work because ketone is highly anti-inflammatory molecule. If you reduce your inflammation with the ketones and ketosis and reduce, I think you can prevent it. If you have any chances like my family had that, should be careful. It's very hard for the kids. Now, UK cancer, they are funding us, children cancer, because they don't want a lot of rise in the childhood brain cancer because of this brownie, cake, and all that. So this funding for is ketogenic diets to prevent. Now, prevention, for the kids, what do you tell them not to eat, all that? But parents are interested. So they are funding, they are giving money. Yes, we need to know that. That's really scary rise in UK. Yeah. So kind of that, but glutamine is another story. We'll talk about that. Anyway, thank you so much.
I was just going to say, is the reason why this has not become the standard of care, or is not becoming the standard of care even in top hospitals in Boston, for example, is it because of the power of the pharmaceutical companies and that they don't want that to actually happen?
First of all, they want to see. Their response is we need to see more. We need clinical trials. And the way they are doing clinical trials, I told you. But when I talked to him, he said, yeah, we know nutrition is important. What do you know nutrition is important? What result you saw this patient? Will you not tell the next patient will come? It's not unethical. Yes, I got the same diagnosis. He got cured by something she is doing on him, and you will not do the same thing for him? No.
Why? Why?
Radiation. Dana-Farber will not be Dana-Farber. Then revenue generation, you know how much radiation, how much money comes from radiation?
Yeah. So it is a finance.
I'm not against radiation. If I have something here, yeah, I'll go for it. No, never, ever. They need to know the biology of the disease. They need to know the cell biology. Now they are knowing. Believe me, we're not going to stop unless we die. We're not going to stop. We are just pushing it. So let's see what happens. Maybe 2 years, you'll see it. Brain tumor radiation should not stop, but they will not immediately. Surgery, yes, because there's a pressure. You're going to die. You need to debulk. First debulk, go for metabolic therapy, go for scan again. Chemo, maybe, little bit of chemo. I'm not against chemo and radiation. It depends on what are you doing, where are you doing, where's the location. Why not, if you have wait and watch time, why should you run for this? Anyone, that's why I came here, just to tell, you never know in your family, someone, that did not happen, but preach that. It's out already, and people are coming a lot. You have no idea. We opened the Pandora's box. Now we cannot manage like so. They're crying over the phone. I don't want to do radiation. They're killing me. I cannot. And I was just telling on the Zoom other day, Cleveland, I should say, why not? Cleveland Clinic's owner, it's on the web actually, that's why. They contacted us. Why? So much money, cannot do something with Dana-Farber? Go there. Helpless. People are helpless when you get that.
Oh, sorry, I just have a quick question. With the diet changes that you were suggesting, are those subject to when you are diagnosed at certain stages of cancer?
Absolutely.
So in other words, if you're stage
If you have a very stage 4 or stage 1, 2, if they want to give you something invasive procedure, just say, I'm coming back. Let me see my diet, lifestyle, glucose, keto. If you're in no, or you don't have time, you think about it. Then you have to see. Maybe pancreatic cancer, that's a disaster one.
Right.
They cured.
Even at stage
Yes, in Egypt, metabolic clinic. They contacted us.
All right.
So Egypt, the big guy, veteran guy, he's retired, and his 2 students, he found the results from his book, after reading this book and his video, Sifritz, and everyone license issue. These 2 young doctors, they have family. They want to go and radiate the brain. It's a job, like bread and butter. And then he told, and they found these 2 little young doctor watch everything and discuss with him. Say, can you please manage our license so we can do little bit of metabolic? We'll do standard of care, mild dose, and we'll do metabolic therapy. Havoc results. That's all the publication is coming from Egypt and Greece, and here also. It's working.
Are we running out of time? Just another quick question as well. I mean, I was just wondering, like the ketogenic diet, so I see that is an approach to prevention. But how does it look like? I'm just wondering, because
ketogenic diet not means a bad food. People think, oh, ketogenic diet, no, you can eat meat.
So
just don't eat carbohydrate. Yeah. 1 piece of meat in the lunch, 1 piece of chicken in the dinner, little vegetable, not a lot of vegetables because that's also carbs. If you are in a bad shape, I'm saying, forget about everything. Forget about that. Just that and little bit of fat, good. Fat is good. Good fat. Avocado, good butter. Go to like organic, I don't know, organic, like good butter, ghee, and little mayonnaise, good mayonnaise. No sugar added in anything. Almond beverage, macadamia nut beverages, nuts. Plenty of foods there. As if you don't eat carbohydrate, pasta, noodle, rice, white bread, no. Sugar, no. I know, it's hard. I know it's hard.
Thank you, Dr. Mukherjee. I'm so afraid I'm not eating any sugar anymore. No ice cream, no cake. Great research, thank you. All right, guests. There's an expression out there that crime doesn't pay. Unfortunately, that may not be true for the global drug trade, which I read has an estimated global value of how much? Any guesses? Billion? $500 billion a year. Yes. In her lecture, business professor Kristin Noon will tell us how global masterminds use business strategy, creativity, and logistics to outmaneuver law enforcement. Dr. Noon earned her MBA and doctorate in business administration from University of Phoenix. With her extensive experience as a consultant, manager, and a leader for a variety of industries, Dr. Noon joined Quincy College faculty at 2017. She teaches courses in the fields of communication, marketing, economics, and management. Please join me in welcoming Dr. Kristin Noon to present High on Supply, Wasted Genius.
I have some tough acts to follow, so bear with me. Hopefully we can end on a high note. I know that was bad. My kids would be so embarrassed. So I want to talk real briefly about the difference between supply chain and logistics and what that means. Logistics is a part of the supply chain. It's actually the movement of goods between, we'll say, houses in order to make a change to the product. So supply chain is actually taking the raw materials, doing stuff with those raw materials, creating a product, and getting it to the end user. We're going to talk about the logistics of moving cocaine from one place to another. And this is a whole slew of drugs, but we're going to focus on cocaine because when I got into I talk about the drug trade in my classes for the logistics and the economic aspects of it. And so I've had an interest in it. And when I got into, like, I have 15 to 20 minutes to talk about this, I'm like, I got to pick just one drug because otherwise we'll never get through this. So I'm actually going to talk a little bit about where it begins so you guys can follow the journey from the start as it grows, literally the coca plants. The couple of areas where, oh, I can't see when up close to my glasses. Colombia, Peru, and Bolivia are where the majority of the coca plants grow. 70% of cocaine, though, is produced in Colombia. So that's where our journey begins. In the coca plants there, plants are harvested, and then they get taken to these secret labs hidden deep in the jungle. And they don't bring all of the plants to one lab. They bring it to a whole bunch of labs. Does anyone know why? Yeah, divide and conquer. That's a good way to do it. Yeah, so they don't get shut down. I heard that over there too. Yeah, so in the labs, this is gross. I didn't know this, but in order to get the coca out, they actually use gasoline and other chemicals. This will make you not ever want to do cocaine. So it uses chemicals. They press the water out, and then typically you'll see on the news the bricks, right? That's literally formed originally in Colombia. And then those bricks of cocaine are then distributed to other parts of the jungle, again, very cautiously, in order to be picked up and transferred to other locations. So we're going to start with the Colombian cartels because, again, this is where the story began. 1970s, though, the Colombian cartels were running into problems with law enforcement in the U.S. Colombia also, in the 80s, agreed to extradition treaty, so it's easier for the U.S. to get their hands on some of those high-end people. So they were like, let's start by having some Mexican citizens transport the drugs over the border on foot. Worked for a little while, but then there were some entrepreneurs in Mexico that were like, we could make some money on this. We have connections in the U.S. Let's work with the cartel in Colombia. And so they finally made some agreements, and now majority of the drugs go through the Mexican cartel to coming into the U.S. We'll call the distributors within the U.S. franchises of the Mexican cartel. So when you think about like a McDonald's franchise, they have to buy everything, right, from McDonald's. They can't get anything from anywhere else. So that's a sort of franchise concept. They cannot use other distributors in order to get the materials. Be careful there. All right, let's go back to the 70s and 80s, right? Flying high. Medellin cartel used to transport, they'd get the drugs to Bahama, put them on an airplane, and then they'd fly them into Florida. They'd land on dirt roads or berms hidden in areas, and that's how they would get the product into the U.S. Fantastic, right? Except Bahama government got some flack from the U.S., and so it was made a lot more difficult for them to do that. Again, this is where the whole transition with Mexico came in. Became too challenging, so they also, along with moving the product in through Mexico, they decided to use some legal methods of getting it in. I'll call it legal methods of getting the product in. In the meantime, though, they still use aircraft, but what they use is a super light aircraft, ultralight planes, sorry, not super, they're ultra. They're even lighter. But they drop the product still in areas. So their planes are still used, but they just don't land. So they actually use cargo ships. So what they'll do is either the product will be hidden, the cocaine will be hidden within the product, or there are false bottoms and false sides within the cargo shipment containers. Great way to get things in there, but we're catching on. We'll stay on the high seas for now. One of the things that the U.S. Coast Guard and Border Protection have found, since 2011, there has been massive numbers of boats coming into the country. And they've caught quite a few of them. So what do? They're like, let's go to submarines and semi-submersibles. You can see this is one of the semi-submersibles. And if you've ever been out on the ocean and you're trying to see anything, including land, it's really hard to see things, and that's like trying to find a kayaker in the middle of the ocean, right? Very difficult to find. But there's a lot of good things we can learn from this. So there are organizations, including the Marine Corps and the Navy, that are looking at the strategies that and the logistics that the cartels use in order to transport goods. And some of the ways that the drug smugglers use logistics on the high seas, it's estimated that only 9% of their vessels get stopped. 9% of everything, right? Submarines and the semi-submersibles, as I mentioned, very difficult to see. Cartels can make a profit even if 90% of their product is caught, right? And again, that's an estimation, but I think it's probably pretty accurate. And we really aren't even close to knowing how much actually is making its way in here. Boat transportation is often only one way. They'll bring the boat in and then they'll sink it after they get the goods off, of course. And then they quickly adjust trade routes. Anytime they start to feel pressure from somewhere, they're like, oh, hey, let's go over here instead, right? Pretty good. Well, logistics of the U.S. Navy and the Marine Corps have been watching this very closely, and some key takeaways that they're finding, and I'm sure you guys know there's been some stuff that we've seen, some aggression from China in some areas where there's water. They use water. So some concerns are that if there was ever any kind of altercation and we needed to get goods or supplies to military operations, we can't do a good job of that because we're big and bulky. That's kind of the way that they described it in the articles. So they want to use less expensive platforms, use smaller vehicles, be more creative with how they get the product there. Change routes quickly. Don't always be like, hey, this is a great route, let's keep going here. Change them more frequently. Now let's hop back onto land, and you guys can take a ride with me to the trucks. We are going to talk about just one person because it was pretty amazing how many years he was doing this for. So Carlos, I'm not going to even try to say his last name in Spanish, though. He's a Mexican citizen who came to the U.S. in 1992 and started his own thriving trucking company. Doing great, but I guess not great enough. 2002, he decided to move into the illegal drug trade, and he was using his logistical skills, his trucks, and his distribution hubs to move 300 kilos of cocaine per week. That's over 660 pounds of cocaine per week. And then guess what? He had to bring the cash back over the border to Mexico to the Sinaloa cartel. So 2002 he started. He was sentenced in 2019. That's a lot of years of profitability, right? Well, why did he get caught? How did he get caught? I don't know, but now they have some new equipment. So the USDA, I don't know if this is how he get caught, but I certainly know that this is a way to keep them from doing this. They use X-ray vehicles. These X-ray vehicles, they're mobile units, and they can see, you know, if there's extra spaces on the floor, on the walls. They can catch things like drugs or cash going either direction. So you know what? That's an obstacle. We can still go back to on foot, right? We've been doing that forever. We'll keep doing that. But we've been building walls, haven't we, right? Right now, there's over 1,000 miles of fence, over 2,000 miles of the border that exists today, 450 of which were built after 2018. So you go up, we'll go down. These are two of my favorite tunneling operations, by the way, we're going to talk about. Tunneling in Tijuana. This happened after a wall had been built in the area that they typically transported drugs. It was from Tijuana to San Diego, and it was part of that Sinaloa cartel, which we talked about a minute ago. And you guys have probably heard the name El Chapo? Yeah. Yes, okay, need I say more? This tunnel was almost a mile long, 5 feet tall, 2 foot wide, electricity, rail track, drainage, ventilation, disco system. I'm just kidding, no disco system. So the Mexican authority identified the tunnel, and it was literally one industrial complex to another. How did they do this? Well, they made sure there was a lot of noise happening all the time. So no one caught on to the blasting and the drilling and all the things they had to do to create this. Now, this is even more of my favorite. KFC Connection, finger licking good. It was from a bedroom in Mexico, dug 22 feet down, 600 feet across, into the basement of a KFC. It was identified by U.S. authorities because the owner of the KFC, or the old KFC, was caught with over $1 million of drugs in his car. And so they're like, maybe we should search his residence and other places that he owns. And there's still more. What else can we do to get over the walls? Well, we can use catapults and air guns. Why not? Brilliant, right? And obviously those are not the catapults and the air guns they used, but they were the only depiction I had. So marijuana is the product of choice, though, for this option. I don't know if it weighs less. Maybe, I'm assuming. Okay, let's get the products into the hands of the consumers. There are 6 key Mexican cartels that transport goods into the U.S. Sinaloa, Jalisco, Juarez, Gulf cartels. You may have heard that name recently with 4 American citizens. Beltran, Leyva. So the cartels transport bulk products into the U.S., and then they're going to give them to distributors to get it to the end user. They use commercial trucking, privately owned vehicles, in order to get the product to where they want it to get to, the end user. Start with larger distribution centers and then get smaller. They move to local criminal groups and gangs to distribute the product. The cartel likes to keep their distance as far as they can from the gangs and from the criminal groups. They tend to get caught easier than the big money people. So, let's talk about farming out the distribution. In business, wholesalers will get product, break it down into smaller quantities, and distribute it. Well, there's businesses in the U.S. that either start out as a legitimate business, like that trucking company we talked about, and happen to fall into the drug trade, or they are literally opened strictly as a front to sell drugs and hide everything, right? So let's take a look at the farming industry. Or a farm, we'll talk about a farm. Farms need fertilizer, so getting large quantities of fertilizer wouldn't raise any eyebrows anywhere, right? Well, the drugs can be packed inside the fertilizer, transported to the farm, broken up into smaller compartments or smaller packaging, and then they're shipped out with their regular products and being sold through that. They are stuck inside meat, or they've even been painted to match the color of tomatoes before. Or actually the containers themselves have, again, false bottoms, false sides to hide the product. Online sales are booming. After we distribute it down to smaller organizations, a lot of products are happening a lot of sales are happening online, using mobile platforms, payment systems, even things like Cash App, very common. They use to make it convenient and less risky. Does the on-the-corner drug trade still happen? Yes. But this is a way for people, again, constantly removing themselves from I'll try not to get caught, basically. So use of cryptocurrencies, bitcoins, help reduce the risk for the buyer and the seller. Pickups are identified for a location, go to this location, or the product. And these are just images I pulled up. Toys can be used, stuffed animals are common. People even have done it inside sculptures. Usually the sculptures are like larger quantities. And of course electronics. Transporting of goods, they do also use trains. One of the best methods for them to do is to have an unwitting person, someone that has no idea they're transporting drugs, do the transporting, because they're never going to look guilty, right? They're like, I'm just driving this old couple's car from Florida back up to Boston. They needed someone, I like to drive cars, or a boat, or an RV, right? So a lot of times they'll use, in even coming across the border, I don't know how they talk anyone into doing that, but apparently some people get talked into doing that. So protective packaging, munchies, It can come in packages that are meant to be crackers, but when you open up, it's not crackers in there. These are around the globe. Algerian Defense Ministry posted this picture of the halal meat. Well, it's packaged containers saying it was halal meat, but it was not halal meat inside. They had one, I watched the video on this for the pineapples. They look like real pineapples. They're not. It's all cocaine inside. I was like, that's ingenious. Because, well, I mean, obviously not that ingenious. They got caught. Thank you. Also in tires, people will put it inside their tires, in their spare. In electronics, you guys are going to love some of these. These are the logistically challenged group. If you can see the arrow in the far corner, this gentleman tried to board a plane with a toupee covering drugs on his forehead. We also have, this is another one of my favorite, these are butt-enhancing shorts that they did not pull one over on authorities. And then I broke both legs, and the drugs were underneath the wrappings for that. So the last thing I will leave you with is, if only cartels had been able to manage the toilet paper distribution during the pandemic, we would have been all set. Thank you. I totally didn't talk too quick. I was trying to like... Thank you. Does anyone have any questions that I can answer? I don't want ones I can't answer. Oh, go ahead.
On the map, it looked like the distribution.
Yep. I'm going to see if I can go back to it.
Yeah, it's about 5 slides back. It looked like the biggest section of red dots was the northeast.
Yeah. I didn't really want to point that out. Yes.
So is that because of affluence or?
Yes, because if we looked at other, yes, because the ability to afford the drug, cocaine, yes. I think that's a very good assessment. So, yeah.
Yeah, I think also that area just have a higher population density overall.
Yeah, that's true too. But I mean, when looking at some of the other drugs, there definitely was a difference in terms of affordability and where people would be buying it. So I didn't choose cocaine for any reason other than it was easier to follow. Some of the other stuff was very complicated. Any other questions? No? All right. Well, thank you all. Oh, wait. Sorry. One more.
I can ask.
Oh, you can ask. Go ahead.
I was just curious. You mentioned that if a route is discovered or revealed, that a trafficking route, if it's found out, they'll find another.
Yes.
You also mentioned cargo ships. So are drugs sometimes taken from Colombia, for example, to another, like an Asian country, and then put on the cargo ships?
Yeah, it can go different. Yeah, it could go to a whole different country, and then in that packaging, make its way back to the U.S. Yeah, yeah. Anything else? All set? Oh, go ahead.
No, it's more like a comment. I mean, it's great that you bring to light some of these things, because I think a lot of strategies and tactics don't have a moral compass. It's up to us what we want to do with it. So we can learn that they have very good strategies, but like in business, we can use a lot of these things in a good way, in a more ethical way. So it's great that you bring to light, some of the things that are being done there, because a lot of these strategies have no moral compass, but we can use fire in a way that's going to be useful for society.
Yeah, there's other organizations that are looking at, I know I just used the military, but there are other organizations that are looking at their distribution system on a smaller scale, because, a lot of times they just take the wholesaler, and then they distribute it in large chunks, as opposed to going like, well, let's go to another distribution center and then another one and kind of break it down that way. In some ways that helps, because then you can transport the product in smaller vehicles, in trucks and things like that, because as you know, we had issues with the 18-wheelers and finding people being able to drive it. So it's not just the military looking at it. That was just, I was running out of time, so didn't talk about it. Anything else? Good? Okay. Thank you all.
Dr. Noon, that was quite enlightening. We know where to go for pineapple party. Thank you all very much for participating in this event. Before we all adjourn to the hors d'oeuvres and refreshments, I would like to ask you for one more round of applause for our tremendous speakers, please. Also, a round of applause for our staff from library, IT, marketing, and facilities for their hard work to put this event together. And QA-TV for generously helping us with the technology for recording and sound system. Guests, this evening's event was just another opportunity to learn with and from our talented Quincy College faculty. There's a sign-up sheet right over there. Please provide your name and your contact information so that we can stay in touch and inform you of future events. And more importantly, please spread the word about Quincy College. Quincy College is proud to now offer not just associate degrees and certificates, but also bachelor's degrees in business management and computer science. And there is more to come. Once more, thank you all again for coming and enjoy the rest of the evening.